Welcome to another biology lesson where we discuss biology from 1, and we're still on topic 2. We are discussing different kind of parts, whereby now we are going to focus much on drawings on biological diagrams. Drawings on biological diagrams. You are with me, George Chapusa, your subject teacher. Stay there as I explain. In the previous lesson, if you may connect, I was explaining on how you might use the potter or the pit trap and the lenses, hand lens for that matter, or the banners. Now we are supposed to focus much on how we may draw diagrams. We might draw diagrams. So here I am going to focus much on the biological diagrams. Now let us focus on what we want to do today, drawing biological diagrams. Of course, a drawing is a figure made to show the appearance of an object or a given part or a specimen. Then it is a diagrammatic representation of that specimen or object. You should also understand that throughout this biology course, you will be required to make careful observations and make accurate recordings of your observations, and observations can be also simple. They can be also a complex requiring the help of magnifying instruments. One of the most important ways of recording the results of your observation will be by drawing. So you'll also prepare records in form of written descriptions or tables. So the following are guidelines on how to make accurate biological drawings of plant and animal specimens. Now let us see how we may follow on how to draw the drawings, the biological drawings. Now 1, draw using a sharp pencil. This sharp pencil will help you to draw a very clear diagram. And 2, pencils, when you make mistakes, you may easily erase them using rubbers for you to relight or draw it again. Then try as much as possible to draw on plain paper so that you have a clear diagram. Then 3, first draw an outline or line of the plant or animal being studied. Then 4, use suitable reference books to identify each structure or part of the specimen and include it in the drawing. Then 5, do not draw a structure before you have identified it, because you will not have accurate parts. You will not put accurate parts or the accurate drawing itself. Then 6, never put aside a drawing to be finished later. Always complete the drawing. If you start drawing, make sure you finish that drawing. Never put it aside to say maybe because of time I should draw it the other time. No, make sure you squeeze that and then finish that drawing within that time. Then make large drawings and leave enough space around them for headings and labels. Remember, large drawings can be easily viewed by many people. So if you make a large drawing and then remember to leave enough space so that when you wish to make a heading of that drawing and then labels of the parts are supposed also to be labeled. So you leave some space so that you put those labels. And 8, place the drawings or place the drawing at a suitable point on the page in the notebook. Do not squeeze it in a corner of the page. Drawings should be clear with thin lines and simple outlines. Avoid shading the drawing. Avoid shading the drawing. So 10, make accurate drawings from the specimen in front of you and never copy from drawings or pictures in the textbooks. Use the book only for reference. use the book only for reference. Then 11, make sure you label everything in every drawing. Everything in every drawing so that you remember what are those parts, and even those people who might also use that drawing must find it easier to use it. Then 12, never cross labels line. The lines should be straight and as horizontal as possible. Never cross the lines. To cross the lines, meaning the lines cutting one another, then you should never do that because you will affect the labeling of the diagram. So the lines should be as straight and as horizontal as possible. That should be in your mind as you make labels of the drawing. So label in pencil and keep the words horizontal. Keep the words horizontal. 14, a line should run from the label and end right in the center of the structure, named and not its edge. So that will properly show the label correctly. So 15, never use arrows to label the diagrams, rather use points. Never use arrows. I think by now you may be in a position to know an arrow, whereby in front of that line you put something which shows like an arrow, but just use a pointer. Thank you. Now let us demonstrate of what we have just shared. We have just shared that drawings are supposed to be drawn in pencils and labeled properly without using arrows. Now let us see what we have here. And now I'm going to give you a specimen and observe it clearly, then draw an accurate diagram. So for me, I have this. So a handrails, of course, can be used to enlarge specimen, which can be seen with the naked eye, but too small to draw. All right? So other diagrams can be drawn without magnifying them, but those specimen which you feel like they are, you can see them with your naked eyes, but they are too small for you to draw. You may use these lenses. If you cannot see these specimen, then it will be tough for you to use the lens, but you might use a microscope. So the diagram below shows a photograph of a maize grain and the biological drawing. So here I have a maize grain for you. This has been a maize grain, and then I have demonstrated how you might draw this maize grain. Now this is a drawing. See, the lines are as horizontal as possible, and the drawing itself also, it is of good size so that you might see it properly, and the parts are well labeled, and then there are no arrows. There are no arrows. At least the lines are as horizontal as possible, and they are straight. So these are the labels of this maize grain. So this has been a very good example on how you might draw biological diagrams. So this has been a biological diagram of a maize grain. View it as you study these diagrams. Thank you. But there is something which you might also see it happening. The kind of labeling has been to one side. Look, the arrows of the labels are going to one side, whereby this could help you to specifically focus on the labels properly. It doesn't mean that labeling using arrows going to the other side is not good, but it is important to label them. But to add more light on that, let us view another type of a diagram which looks like this one. This has been a diagram, but the aim of this diagram to bring in a variety of what we have just shared. But this is also another figure which shows a various biological diagram, I should say. So this is a plant diagram, and it is showing external parts of that plant. So this could be also another nature of a diagram. Not to end there, there is another type of a diagram. Yes. So this also has been a diagram, and this is also showing external structures of the leaf. External structures of the leaf. But now, these are just drawings. These are just drawings. As you draw, you always remember that you draw something which maybe it was real, a specimen. It was a specimen, and then you are making it as a drawing. But as you draw, you may make the drawing bigger than the actual specimen, or you may make the drawing smaller than the actual specimen. So in biology, you will also be required to calculate the way how you have magnified that drawing, the way how you have magnified that drawing. So the next part, we are supposed to also know how we might calculate magnification. How we might calculate magnification. So this part will learn on how we might calculate magnification. Like what I've already said, drawings can be bigger, drawings can be smaller than the actual size of the specimen or the object. So you might calculate how bigger you have made that diagram or how smaller you have made that diagram. So that's what we call magnification. So a biological drawing may be bigger or smaller than the object observed. You can compare the length of the drawing with the length of the object by measuring the length of each. I mean each, which means the specimen or the object and the drawing. Yeah, so the measurements you get are used to determine the magnification of your drawing. So those measurements, they will help you to calculate or to determine the magnification of that drawing. Now, this is the magnification formula. If you are to calculate magnification, here is the formula where you divide the length of the drawing or image, the length of the drawing or image, you divide with the length of the specimen or that object or the object. So this is the formula which you also need to keep in your mind as you are studying biology. The other time you are asked on how to calculate magnification, remember that this is the accurate formula that we may give you to calculate magnification. Now, for instance, if a leaf is 20 centimeter in length and has a drawing of 50 centimeter in length, how could be the magnification? How can you calculate the magnification? So magnification of a drawing could be like this. It means you put length of the drawing, which is 50, you divide with the length of the specimen or the object, which is 20. And this, as the answer, it gives you 2.5. Or in other words, that could be 2.5 of that image. Yeah, so the answer is supposed to be presented like this. The magnification is supposed to be presented with an X in the beginning. This means it is 2.5 times bigger than the actual specimen. 2.5 bigger than the actual specimen. Or you might say this means the drawing is 2.5 times bigger than the actual length of the specimen. The actual length of the leaf specimen, that kind of thing. Yeah, so that is what you need to know. So again, it is also possible to have a drawing smaller in size than the drawing. Still more, you need to indicate that number and the size which, how smaller it is. Yeah, thank you very much for being a very good listener. And next time we meet, we shall discuss a very interesting lesson of recording measurements. Recording measurements. That has been George Chapusa for now. I thank you for being a very good listener and always keep practice to what we always share. Thank you very much for being a very good listener and a very good learner for that matter. I thank you for loving biology. Thank you.